Hi guys, welcome to today's Cloud Core Plaza. I'm Summer from Huawei Cloud Core Network Department. Today we invited the Managing Director and Vice President of ABI Research, Saunders. He will lead us understand the evaluation of telecom cloud technologies and the future of container deployment. Hey Jake, first question. As we all know, the telco cloud technology evaluation is moving to containerization. Could you briefly introduce what are the containers and why we need containers?
A container is essentially a software abstraction or virtualization layer. Containers are attractive because they are lightweight in terms of usage of memory and computational processing, and therefore they can offer the operator still an independent operating system virtualization. When you compare containers with virtual machines, containers do come across as more process level, more resource isolation technologies. That's what they do at heart. But let's go deeper. Let's delve into some of the technologies. These solutions also offer independent, essentially a guest operating type experience. Because they're virtual machine based, there is some moderation in performance, but you put that to one side, the fact that this container as a service is fully decoupled from the infrastructure. It means the hardware is effectively invisible to the infrastructure as a service layer.
Second question, can you briefly compare VM containers and bare metal containers in terms of their performance, security, and application maturity?
So therefore, these virtual machine-based containers only take a few seconds to spin up and be created if the virtual machine is up and running. But yes, if the virtual machine is not up and running, then yes, you've got to add the two together. It's the VM time plus the container startup time in terms of spin up. But at its heart, virtual machine-based containers are a mature, are a stable technology, and certainly ABI Research has seen a number of mobile operators commercially using VM-based containers in their 5G core. On the other hand, when you're looking at sort of bare metal containers, they have to share the kernel and the OS. So yes, that does make them a lot lighter, but they do offer a weaker isolation. The performance of bare metal containers is definitely essentially the same as that of bare metal services, and therefore only takes a few seconds to create or spin up. However, when you're looking at sort of communication technology scenarios, when you look at the underlying technology, the software standards that underpin bare metal containers, they're not expected to fully mature until after second quarter 2022. So therefore, right now, they're not ready for commercial use.
Last questions. For containers deployment, some technology-driven operators prefer to use CNF and CAS platform from different vendors. What are the challenges to decouple CNF and CAS platform?
Well, challenges, yes. Well, there are actually a lot of challenges, several challenges when implementing cloud-native network functions, and when you combine that with containers as service platforms from multiple vendors. And that is the key issue, multiple vendors. There are compatibility issues when you couple the CNFs with the containers as service from a technical point of view. Instances I can refer to is, for example, the OS can't assure that the interface is fully compatible. The virtual network function vendors will have to release a series of iterations which will require their own test and verifications. It also means that there needs to be a combined upgrade of the container as a service as well as the CNF. And therefore, what all that means together is even a minor container as a service update means you incur an upgrade for all the virtual network functions on the network. Other facets to consider relate to, for example, greater integration that's needed, also issues revolving around the operations and maintenance effort that's required. And this comes down to the fact there are simply more interfaces in the container as a service compared to a hypervisor type installation. In all, ABI Research estimates there's about 300 interfaces, and therefore the container as a service and the CNF are very tightly coupled. If both network components do come from a single vendor, however, then the operator and the vendor only need to test their own container as a service. If, however, on the other hand, the operator has taken a multi-vendor approach, then the CNS vendors' containers have to be tested and also verified with the different container OSs. And this is challenging because there is a large interface surface exposed. The last items I'll bring your attention is the fact that when you're looking at end-to-end operations and maintenance, it can also be challenging because the container as a service and the CNF, if they come from different vendors, then the operator is faced with substantial efforts in terms of 1, carrying out integration, 2, additional testing, 3, in terms of then the troubleshooting they need to sort out. The last facet also to consider is 5G requires a containers as a service enhancement. That enhancement is dynamic function exchange, and that has to be implemented within the operator's 5G core. This is because the current Kubernetes stack is very much focused and revolves around IT scenarios, and therefore it needs to be enhanced to meet telco, to meet communication technology requirements to be truly effective.